Hello students, welcome you all to the video lecture. Today we are going to find out the pole zero plot using MATLAB software. So we are going to simulate and find poles and zeros in the Z domain signal, as well as we are going to sketch the pole zero plot using the MATLAB software. So suppose if the question is given and it is h of z, which is equal to 1 plus 3 z inverse divided by 1 plus 3 z inverse plus 2 z power minus 2. If this is the question, for this question we are going to find what are all the poles, what are all the zeros, and we are going to plot that signal in the MATLAB software. Okay. So first of all, generally we need to know how we have to find out the zeros, how we have to find out the poles. So first convert the z inverse terms into z terms. So how will you convert? Just multiply by z square. So here it will become z square plus 3 into z square into z inverse is z. Okay. So denominator here it is z square plus 3z plus 2. So numerator and denominator we have to multiply by z square. Why? Because the higher power term in the denominator is z power minus 2. So we are multiplying commonly both in the numerator and the denominator by z square. So once we have converted like this, we are going to factorize the numerator and denominator separately. So here we can just take z outside. So it becomes z plus 3. The denominator we need to factorize. So 2 ones are 2, 2 plus 1 is 3. So this I can write as z plus 2 into z plus 1. Okay. So numerator I have factorized like this, denominator I have factorized like this. Numerator equate it to 0, so that will be giving the zeros. Denominator equate to 0, that will give the poles. So zeros are calculated by equating the numerator term to 0. Okay. So what happens? Z equal to 0 and z plus 3 equal to 0. So z equal to minus 3. Okay. Similarly, for finding the poles, we need to equate the denominator to 0. So when we equate this to denominator to 0, z plus 2 equal to 0. So z equal to minus 2. Z plus 1 equal to 0. So z equal to minus 1. Okay. So two zeros are available. One exists at z equal to 0. One exists at z equal to minus 3. Two poles are available. One is at z equal to minus 1. One at z equal to minus 2. So generally in the manual calculation we will plot like this. That is, this is your real part of z. X axis is real part of z, y axis is imaginary part of z. So what are all the zeros available? We will make it as a circle. So at 0 we will just put a circle. At z equal to minus 3. So here at minus 3 we will put one circle. Similarly z equal to minus 1. So minus 1 we will put one cross, and minus 2 we will put one cross. Okay. So poles are given by cross and zeros are given by circle. So like this we will usually draw the poles and zeros in the z plane. Okay. And then again, in order to generally we will draw one unit circle in order to just give the stability condition. So whenever we can say that whenever the poles are inside the unit circle, then it is said to be a stable. If it is outside, that system is said to be unstable. So generally we will draw one unit circle also. So since this is at minus 1, definitely this will cross at 1. Okay. So we will draw a unit circle. So this is the plot. So let us try in the MATLAB software how to execute this zeros and poles plot in the MATLAB software for the given h of z. So in the Google you just give MathWorks. So it will give this link mathworks.com. So just to sign in it. So I have already created the account. So if you are using this for first time, you just sign up and then come. Here you have MATLAB, okay, so that you can click it. So we can open MATLAB online basic. So you have options like you can get the MATLAB for 30 days trial version, or you can use it for 20 hours in a month. Online you can use it for 20 hours, okay. So like that you can do. So here I am going for the new document, okay. So you just start giving your program, okay, then finally we can save the program. Without saving the program also we can run, but while running it will ask us to save the program, okay. So when we have the equation, see the numerator is what? H of z is 1 plus 3 z inverse, right. So we have actually 1 plus 3 z inverse, okay, this is the numerator term. And then what about the denominator term? 1 plus 3 z inverse, okay, plus 2 z power minus 2, okay. This is the numerator and this is the denominator term of your h of z. I am just recalling it, okay. So whatever the numerator available, okay, whatever the numerator available, the coefficients, okay, of z power 0, that followed by z power minus 1 followed by z power minus 2, that we have to consider it as a vector, okay. So the numerator coefficient let us take as a, okay, and give inside the square bracket. So we have what are all the coefficient in the numerator? 1 and 3. So you give just 1 space 3, okay, and then the denominator coefficient is b, okay. So that we can give again using the square bracket. So what are all the coefficient? 1, 3 and 2. So 1 space 3 space 2. So always we have to use the semicolon to just end the line, okay. Then we are finding out the roots of both numerator and denominator. So let us consider it as p equal to, okay, roots of the numerator term, okay, and then q equal to roots of b, okay, and then we can give z plane of a comma b, that is numerator coefficient and denominator coefficients, okay. So this z plane of b, what it gives means it will directly plot the pole 0 plot, okay. So we don't want to give or plot the signals, okay. Z plane just give the plot itself, okay. It will plot the zeros and the poles whatever we have given as a vector, okay, and it will generate the figure. So if you want to give the title for the figure, we can use title, okay, and then we can give as pole 0 plot. Okay, so like this we can give and we can execute, okay. So this one I don't want, so just give percentage, this will become a comment. Similarly give the second statement as also comment, okay. So this one is what? Numerator coefficient, this one is what? Denominator coefficient, okay, just for your reference. And then here you are finding out the roots Okay, let me give here generally. Okay, I am finding out the roots, meaning that finding out the zeros and poles using the following command, and then I am plotting the pole 0 plot. Okay, so once you have given everything, you can just run the program. So if you want to give any title, you just give any title for this. Okay, so let me consider it as pole 0 PLT. Okay. So once you have saved and run the program, then because of this instruction, that is a z plane of a comma b, the pole 0 plot will be available, because this z plane of a comma b will plot the pole 0 plot automatically. So no need to give the plot command here. Okay, so we can compare the problem which we have already solved. So zeros occurs at z equal to 0, z equal to -3, poles occurs at -1 and -2. So poles are represented by cross mark, which is available at z equal to -1, z equal to -2, and then zeros are available at z equal to 0 and z equal to -3. Okay, so z equal to 0 and z equal to -3, the zeros are available. So as what we have plotted over there, here also the unit circle is represented. Apart from the zeros and poles, unit circles are represented. So here the title has been given, so that also automatically above the plot it will be displayed. So suppose when coming to the command window, actually this is the roots, right? This is the zeros and this is the poles which we have to view in the command window. But when we see the command window, nothing is there, just the name, file name only is displayed. Okay, so suppose we want to display the roots. Okay, so what we can do means just remove this semicolon. Okay, so that, what do you mean by that? Whatever the values here, it will be displayed in the command window. Okay, so if we remove the semicolon, meaning that this particular value we are going to display in the command window. Okay, so let me check. Let me run again the program. Okay, and see the command window now. Okay, so this is the already thing which we have received, only file name we received. Now, so if you want, you can just drag the command window above so that it will be visible properly. Okay, so p equal to -3. Okay, q equal to -2, -1. Okay. So when we see the command window, we have not obtained the zeros value properly, that is z equal to 0, that also should be displayed, but it is not visible here. Just compare the problem. Here the constant value is there, and then z inverse term is there, and then z power -2 term is there. So only we have given in the starting the vector as 1 space 3 space 2. So numerator we have taken as 1 space 3. Okay, so we are not getting the z term properly, zeros properly. Why? Because we didn't given z power -2 value. Okay, so while doing the program, you should consider that properly. So when you see the pole 0 plot is proper, but when we see the roots, we are not getting the roots properly. Why? Because z power -2 coefficient we have to give, which is nothing but 0. Okay, so now run the program. Okay, so pole 0 plot as what we have obtained previously, it is there as it is. Okay, and then now see the command window. So this is the value which we have obtained previously. Now see, it is properly coming. Zero values are nothing but one value exists at 0, one value exists at minus 3. Okay. So if you want to properly get the value of the particular program, just clear the command window. Okay. If you want, you can close the figure window also. Just run again one more time. Okay. So the pole 0 plot is displayed, as well as in the command window, just drag above. Okay. This is the zeros value, this is the poles value. So 0 exists at z equal to 0, z equal to minus 3. Pole exists at minus 2 and minus 1. Okay. So again, whether it is necessary to remove the semicolon and we have to display the value, the another option is, instead of removing the semicolon, we can just display, okay, the value of P and Q. Just give the command display of P, display of Q. Okay, so that no need to remove your semicolon. So like this also you can execute. Okay. So just I am closing the figure as well as clearing the command window. Okay. Now I will execute the program. Instead of removing the semicolon, now I have given display of P, display of Q, so that in the command window the values will be displayed properly. Okay. So in this way you can run the program. So what we have to do, we have to give the numerator coefficient and denominator coefficient properly, such that all the values it should exist. Okay. Thank you. Thanks for watching.